Hello everyone, we're going to be going over section 3.4, which is about the slope-intercept form of a linear equation. So we're going to have four objectives today. Our first objective being that we want to use slope-intercept form of the equation of a line. We want to graph a line using its slope and a point on the line. We want to write an equation of a line using its slope and any point on the line. And then finally, we want to graph and write equations of horizontal and vertical lines. So objective 1, we want to use the slope-intercept form of the equation of a line. So recall from our previous section that we can find the slope of a line by solving the equation of the line for y. So whatever our equation is given in, we want to solve for y, and when we do, our new equation is going to be the equation of our line. So we're solving for y, and then once we do this, we say that the slope is just our coefficient of x. So for example, if we end up with an equation of y is equal to 2x plus 3, our slope is 2. It's the coefficient in front of x. But in this case, what does the 3 represent in something like y is equal to 2x plus 3? If the coefficient 2 means something, then 3 should also mean something. So we can assume that a line has a slope m, which in this case is 2, and its y-intercept is going to be at the point 0, b. Then we can choose another point, x, y, on the line and use the slope formula to find the equation of the line. This is shown below, so we'll take a look at this picture here. So we see if we choose this x and y and our y-intercept, so b and 0 is our y-intercept, and x, y is just another point. So we're using our y-intercept and this other point, and we're just using them in terms of x, y, and b. In this case, we're not working with our real numbers. And we say that our slope is equal to y minus b divided by x minus 0, indicating our change in y values over our change in x values. So simplifying the denominator, this is just going to give us m is equal to y minus b over x. Then we can multiply x to both sides, which gives us m times x is equal to y minus b. And then we add b to both sides to isolate y. And when we do this, we end up with the form of y is equal to mx plus b. And this result, this y is equal to mx plus b, is the slope-intercept form of the equation of a line. So we can read the slope and y-intercept of the line from this form that we're given. Whenever we solve for y in any sort of equation of a line, even if our equation is not given in terms of y, if we just rewrite our equation so that we solve for y, we end up with our slope-intercept form. And then when we do this, we can read our slope and our y-intercept straight from that equation. So in the case of something like y is equal to 2x plus 3, our slope is 2 because it's the coefficient of x, and our y-intercept is just 0, 3. So it's whatever value you are adding when you have your equation for y. So the slope-intercept form of the equation of a line with slope m and the y-intercept 0, b is y is equal to mx plus b, where m is our slope and b is the y-intercept. Or when we write it as 0, b, since when x is 0 and y is a value, that is going to be the y-intercept. So whatever that value is of b, you always want to write it as parentheses 0, b, end parentheses. That's how we would write our y-intercept in that case. So the slope-intercept form is an especially useful form for a linear equation because of the information that we can determine from it. If we can always rewrite an equation into our slope-intercept form, then we can tell right off the bat what our slope is going to be and what our y-intercept is going to be. So that's why we really like using our slope-intercept form. It is also the form used by graphing calculators and ones that describe a linear function. So normally when you describe a linear function, it will be given to you in your slope-intercept form. And whenever you use graphing calculators, this is the form it also likes you to put it in. All right, so objective 2, now we're going to actually graph a line using its slope and the point on the line. So we can use the slope and the y-intercept to graph a line, and we have 4 steps here. our step one, we want to write the equation in our slope-intercept form if necessary by solving for y. So if our form is not already in slope-intercept form, we want to rewrite it. Step two, we want to identify the y-intercept, and then we're going to plot the point 0, b. Step three, we identify the slope m of the line. Then we can use geometric interpretation of slope, or rise over run, to find another point on the graph by counting from the y-intercept. Step four, then we want to join the 2 points with a line to obtain the graph. If desired, you can obtain a third point just to make sure, such as the x-intercept. Let's check. So saying this, let's go ahead and do our first example. So our first example, we want to graph the equation of the line using the slope and y-intercept. We have that y is equal to 2/3 x minus 1. So for our, too big. Oops, there we go. So for our step one, we want our equation in our slope-intercept form. And we see here that our equation is given in our slope-intercept form. And we can even rewrite it a little bit more, because what we see is we have a y is equal to mx minus b. But we know that subtraction is the same thing as adding the inverse, so we can rewrite this as y is equal to 2/3 x plus -1. So now we're in the true form. Step two, we wanted to identify the y-intercept. Our y-intercept is our value of b. So remember here, this is y is equal to mx plus b. So our b in this case is going to be -1. So our y-intercept is going to be at 0, -1. And we want to plot this on our graph. And we are going to plot these points in black because our graph is in green. We don't want to be too confused. So our y-intercept is going to be at 0, -1. So right here we can say 0, -1. We know this is the y-intercept. And now step three, we want to identify the slope, or as we call it, m. Remember slope. So our m is just our coefficient in front of our x, which in this case is going to be 2/3. So our slope is 2/3. And now we're going to use our geometric interpretation to plot a second point on this graph. So we know that our slope is rise over run. So in this case, if we have rise over run, 2/3, we have rise over run, this means that rise is equal to 2 and run is equal to 3. And when we rise, we go up, and in our run, we're going to go to the right. We have a positive value, so we move in the right direction. If we had a negative value, we would move in the left direction. But so we want to go up 2. So from our y-intercept, we're going to go up 1 to 0 and up another to 1. So we've gone up 2. So we say rise is 2. We rose 2. And now our run is going to be 3. So we want to move 3 spaces to the right. So we're going to this point here, which is 3, 1. And we've rose and we've ran. So now we plot our point. And our point here is 3, 1. So we've plotted our second point. And now we want our last step here, step 4, which is now we just want to connect our dots and draw our line. So as best we can, we connect our dots. And then since we're drawing our line, we're just going to draw a little bit of a line and an arrow out from each end of our dots as well. And here we have our equation of our line, which is that we were given the equation of our line. Now we have shown the graph of our line. So this line here. Now we can plot that third point like it does mention in step 4. We can say if desired, obtain a third point such as the x-intercept as a check. So we could do this as well. Step 4, we connected dots. So that's what we did there. I didn't fill that in. And now we say as a check, we can solve for the x-intercept. So if we do, we know we have y is equal to 2/3 x minus 1. So now we just solve for x instead. So we can add 1 to both sides. We get y plus 1 is equal to 2/3 x. Then we can multiply each side by 3. There we go. We multiply each side by 3, so we're going to get 3 times y plus 1 is equal to now 2x. Since we've multiplied by 3, we canceled our 3 in our denominator. We can distribute our 3 to get 3y plus 3 is equal to 2x. And now we divide each side by 2. So now we're going to have 3/2 y plus 3/2 is equal to x. And we find our x-intercept by plugging in 0 for y. So remember, we find our x-intercept by plugging in 0 for y and solving for x. So if we plug in 0 for y in this case, we're going to get 3/2 times 0 plus 3/2 is equal to x, where 3/2 times 0 is just 0. So we get that x is equal to 3/2. So our x-intercept, about to run out of room, is going to be 3/2 0. Now we can go to our graph and plot this point as well. So our point was 3/2 0 on our graph. 3/2 is 1.5, which is about right there. So we do have that third point, and it does fall in line with the graph of the line that we plotted. So all right. Moving on to objective 3, we want to write an equation of a line using its slope at any point on the line. So we can use the slope-intercept form to do this. Example 2, we want to write an equation in slope-intercept form of the line passing through the given point and having the given slope. Then we want to graph our line. So since we're given a point and we're given our slope, we need to go ahead and we need to find out where these points are going to go, or what our equation is going to be. So what we can do to find the equation of our line we can plug in the points 2, 5, where now x is equal to 2 and y is equal to 5 into our slope-intercept form. form to solve for b. So it was a bit long-winded there, but the point is we know what our slope is. We have this point, so we're going to plug our point into our slope-intercept form and solve for b, because b is the only variable in this case that we don't know. So our equation, which is normally y is equal to mx plus b, is now going to be 5 is equal to 4 times 2 plus b. So 5 is equal to 4 times 2, which is going to be 8, plus b. We want to get rid of our 8, so we will subtract 8 from both sides to get 5 minus 8, which is going to be -3, is equal to b. So we have that b is equal to -3, which means that our y-intercept is at 0, -3. And since now we know our y-intercept, we know our value of b, and we know our slope, we can create our equation of our line. So we know that now we're going to get that y is equal to 4 times x minus 3. And this is our equation. So given our problem, we want to write the equation in the slope-intercept form of the line passing through the given point, and having the given slope. Now we want to graph the line. So we're going to do the same thing as we did in our last problem to go ahead and graph this line. So we have our equation in our slope-intercept form. So step 1, we have y is equal to 4x minus 3. Step 2, we've already identified our y-intercept. We know it is 0, -3. Step 3, we identify our slope, which was given to us. It is 4, which means that our rise is 4, and our run is just going to be 1, since it is technically 4 divided by 1. So plotting our y-intercepts at 0, -3, we're going to have our point right here. So we have 0, -3. This is our y-intercept. And our slope, which is 4. So we're going to rise 4, run 1. The other thing to pay attention to is that we were given a point. So let's go ahead and plot that given point. Our given point was at 2, 5. So when we plot this next point with our slope, we want to make sure that it's going to fall in line. So we want to rise 4. So from -3, we want to go up 4, which is to +1. So we have that rise is equal to 4. And our run is just 1. And now we plot our point, which is going to be at 1, 1. And when we draw out our lines, we want to draw them as straight as possible. So let's go ahead and draw a line, which is, let's fix this a little bit. And pull through, come on. Close enough. The settings here in OneNote when we draw our line are not quite smooth. They kind of move in jerky directions. But we do see here that if we draw a straight line, it will go through each of our dots. And since there were 3 points, there's no real reason to check and try and find an x-intercept since we have 3 points as well. So this here is our graph of the equation of our line that we found. So, all right, our last objective, objective 4, we want to graph and write equations of horizontal and vertical lines. Example 3, we want to write the equation of the line passing through the point 2, comma, -2, and having the given slopes. A, we have that slope is equal to 0, and B, we have that our slope is undefined. Then we want to graph our lines. So we can start by just plotting our point. We know that the point is 2, comma, -2, and both of our lines are going to go through 2, -2. So we find 2, positive 2 on our x-axis, and we go down -2. Let's plot this. So we have our given point, 2, -2. And now for part A, we're saying that our slope is equal to 0. Well, we know what our slope is, and we have a point, so we need to find B. So using our equation, which was y is equal to mx plus b, we can now write this instead as -2 is equal to 0 times 2 plus b. So 0 times 2 is just going to be 0. So you have -2 times 0 plus b, and we have -2 is equal to b, which means that our y-intercept is at 0, -2. So let's go ahead and plot our y-intercept. Let's plot this in red. So our y-intercept is at 0, -2, this point right here. So 0, -2, this is our y-intercept. So what we do now is that we want to connect our points. And we want to connect our points here, but we see we're going to have a straight line when we do connect our points. And we can just pretend that that looks straight. There we go, straight enough. So we've connected our 2 points, and what we see here is that we just have a straight line. And if we remember correctly, if we have a slope of 0, this means that we're going to have just a horizontal line, which is in the form of y equal to b. And since we now know our y-intercepts, and we know that our slope is 0, we would get y is equal to 0x minus 2, which means that our equation is just y is equal to -2. And this is a horizontal line, which we have graphed. Now for part B, we have that our slope is undefined. Since our slope is undefined, we can't actually plug in any values for our slope, so we can't really go about this problem the same way as we did part A. Since our slope is undefined, it's key to remember that in this case, when our slope is undefined, this means that we have a vertical line. So we have a vertical line in this case. Vertical lines, or vertical line equations, have the form x equals to a, where in this case, our point that we were given, our 2, -2, is in the same form as a, comma, b. So if the equation has a form of x equals a, and the equation or the point that we were given was 2, -2, then we get that our equation is just going to be x equal to 2. And we can go ahead and we can highlight these equations that we have. We'll go ahead and we will plot this in blue. So if x is equal to 2, then this means that our x-intercept is going to be at 2, 0, 2, 0. This is our x-intercept. And we draw our vertical line going through our point, which was 2, -2. Let's just draw over that again. So those are the key things to pay attention to when graphing horizontal and vertical lines. The main thing you want to remember is that if your slope is equal to 0, you have a horizontal line, and if your slope is undefined, you have a vertical line. And then remembering what equations go along with those ideas. So horizontal lines have equations like y is equal to b, and vertical lines have equations like x equal to a. All right, so that finishes up our section 3.4. So I will see you again in section 4.1.